performing lab number 9 of Dsp. So basically in this lab we have to find transfer functions and then plot the poles and zero on that transfer function. So here we define the numerator of the transfer function and here we define denominator. This line basically it is finding the transfer function using numerator denominator, and this is sampling time, and this is our variable z, where this means that the poles and zero are on z plane. Frequency response, this line is finding frequency response, and the last line is finding defining that the numerator and denominator are on z plane, which is a complex plane. By running this code, so here you can see we have a 0 on origin and pole on this location. In task 2 we have numerator this and denominator this. Again we are using the TF function, which is used to find the transfer function, and this is frequency response, and z plane we have a poles and zero on z plane. By running this we have poles and zeros like this. In task number 4 we have numerator 1 and denominator this, and we have additional things like a equal to roots num and b is equal to roots b. Then we are defining again the transfer function and the frequency response. So running this code, now you can see we have a root numerator here and root b here. Task number 5, simply we have to find the transfer function and the poles and zero by using this code. Running this code, so we have output like this. We have a pole on here and we have a zero here. So in this code we have numerator this, denominator this, and transfer function like this, and frequency response here, numerator and denominator here, z plane where numerator and denominator are going to show a is equal to roots num and b is equal to roots b. Running this code, we have on a root a. So this is the in task number 7 we have numerator this, we have denominator this, and transfer function num, numerator denominator, sampling time variable, and z cap is equal to -1, and then we are using frequency response, and then we have z plane. Running this code we get output like this. Here we have a pole on -0, and then we have two zeros here and one zero is here. This is our output. In task number 8, numerator we define here, denominator here, and this is our transfer function. This is our simple code just to find the transfer function, and then frequency response and plotting zeros and poles on the plane. So this is our output. In task number 9, we have defined numerator, denominator. This is our by running this code we get output like this. Here we have our transfer function, there's sampling time here, discrete time transfer function. So this is lab number 9 DSP. This is our poles and zeros.